Sure, you can do that.
Okay, I'm Randall Engle. I'm a professor at Georgia Tech School of Psychology. I was chair of the department for 13 years. Now I'm professor in psychology and director of the Brain Imaging Center here at Georgia Tech. I do work on individual differences in working memory capacity. Working memory, the term's actually been around a while, even before Baddeley and Hitch. Baddeley and Hitch, most people would trace that term back to Baddeley and Hitch 1974 chapter. Study of short-term memory has been around since at least 1958-59. But what Baddeley and Hitch argued was that working memory is a much more complex system. Baddeley and Hitch and many of the other researchers and theorists on the Atlantic side of this problem think of working memory as a very structured system with what they call a central executive, but a phonological store and a more visual spatial store. They've added some other things to it. On the American side of the Atlantic, all along from almost the very beginning, we've thought of working memory much more so in terms of a functional system of an interplay between all of the memory systems and attention. So the individual differences that I study would generally be thought of within the framework of Baddeley and Hitch's central executive. So let me tell you how I got started. I've been working on this problem for 30 years or so. In 1980 and 1983, Meredith Danneman, a graduate student at Carnegie Mellon, and her professor, Pat Carpenter, published papers showing that simple measures of short-term memory, like the number of letters one could recall or the number of digits one could recall, simple span tasks, really didn't do a very good job of predicting performance in real-world situations. And we'd actually known that for a while. Robert Crowder, in a very famous paper in the Philosophical Transactions of the British Society, argued, the title of his paper was The Demise of Short-Term Memory. Even though short-term memory had been studied and thousands of papers on short-term memory, one of the arguments that Crowder used for the demise of short-term memory was that measures of short-term memory really didn't tell you anything about people's performance in the real world. And that's a bit of a problem. So you can study something like the number of letters you can recall, things that affect that, like whether the letters are phonologically similar or not, and find some interesting effects. But if it doesn't have any impact in the real world, why study that, right? I mean, one doesn't have to be an engineering psychologist to understand that what experimental psychology is about at its best is taking a real-world problem, something out there in what I call the junkyard of life, bringing it into the laboratory where we have total control, where we have control over as many things as possible, and study it in this petri dish of the laboratory. But hopefully we never lose sight of the fact what we're studying is a problem out there in the real world. And periodically, as I tell my graduate students, we have to sort of iterate between studying this thing in the lab and making sure we haven't lost touch with what's out there in the real world. So Danneman and Carpenter showed that if you had people do a task in which they read a sentence and then they read another sentence, and the task was to remember the last word of each sentence. And you compared that with a task where they just had to remember the words that were the last word of each of those sentences. That this, what they call a reading span task, predicted performance really well in a lot of real-world situations. And I remember reading the 1980 paper, and what they showed was that performance on this reading span task predicted reading comprehension very, very well, particularly something called pronominal reference. So if you're reading a paragraph that Fred and Bill were roommates, they went to the store, Fred bought some nachos and some beer, Bill also bought a six-pack of beer, but he bought some ice cream. On the way home, they were in an accident. Fortunately, nobody was hurt. The car was damaged. But when they got home, he quickly put the ice cream in the freezer. When you get to he, you have to refer back to who bought the ice cream. That's called pronominal reference. Well, it turned out that this reading span task predicted comprehension of pronominal reference at a 0.9 level. Now, I remember reading that paper. The N was very low. It was like 19 subjects or something. It was just a not well-designed study. And I remember thinking, well, gee, that's not, what you've shown here is that people who read well read well. Not a very interesting finding. That is, this reading span task really is measuring reading, followed with memory. And so I designed this little study that I had my graduate student go and perform, in which we designed an operation span task where people did a series of arithmetic and followed by a word. And I was convinced that what we would find is that did not predict comprehension at all. And seriously, at the time, I thought we'd do that study, show that that study was flawed, and move on to something else. And what we found, in fact, in a series of studies, and now 35 years later I'm still doing the research, was that the operation span task, in fact, predicted performance in reading comprehension as well, and sometimes better than the reading span. So it was not just reading predicts reading. It really was measuring something important. Danham and Carpenter really didn't pursue that issue. I took it on, so it's basically that's been my problem for all these years. And I think it's safe to say that I've really started a whole area around this issue of individual differences in working memory capacity. And a lot of my work has been directed at trying to understand what that is. And what is the nature of these individual differences? Where do they come from? What causes them? And I've combined both psychometric methods with experimental methods, and in my lab we really do combine the best and worst of both worlds. So Lee Cronbach in his presidential address at APA in 1957 did a speech in which he called the two schools of psychology, in which he argued that psychology throughout its entire history, and it goes all the way back to Wundt, in fact, there's been an experimental side and a psychometric side, a differential side, and that those two approaches rarely speak to one another, and that's still the case today. And they have very, very different perspectives, and that is the case. In my lab we do both, but I can look around the table in my lab meeting and I can tell you who in that lab has the personality of an experimental psychologist and who has the personality of a differential psychologist. And they can know all the techniques, all the methods, but people tend to think in one of those ways. And I'm ambidextrous. I really tend to think both ways. So following that finding that the operation span task did as well as the reading span, I was interested in why is that the case? And so published a paper with Marilyn Turner. She was a graduate student at the time, Turner and Engle, and it's my second most cited paper. It's been cited well over 1,000 times. And, which showed that, you could manipulate lots of things. You could manipulate the nature of this processing portion, either the sentence or the arithmetic, the nature of what it is to be remembered. None of that really made a lot of difference. But this procedure of using this complex span predicted performance in a huge array of real-world situations, everything. And it wasn't just reading comprehension. It was following directions in children and adults. It was whether it was map directions or verbal directions, didn't make any difference. Just a whole range of educationally relevant situations were predicted quite well by this, what I call dippy little task, because it is. When you think about it, it's this, you're doing some simple arithmetic in the operation span task. Is 6 divided by 2 plus 1 equal to 5? Yes or no? And then you get something to remember, and it could be a letter or a word or a visual figure of some type. None of that makes a difference. And why would that dippy little task, where you have to pay some attention to some arithmetic, even very simple arithmetic, and then remember something, all of a sudden make this task valid in a psychometric sense? That is, it's valid in that it predicts performance in a huge array of real-world situations. And it's also got high reliability, it turns out, and stability across months and months of testing. So much of my work has involved why does that occur? What is the nature of that? And so that led me to doing, the regression studies led me to doing large-scale structural equation modeling studies. And so most of my big studies over the years, certainly since 1995 when I came to Georgia Tech, have been large-scale regression studies. So I've got one of the first JEP general papers that was a structural equation modeling study in 1999. It's been cited, 1,500 times, something like that. I mean, it's a widely cited paper. It's my most cited paper. And, and what that was all about was treating this at the construct level. And so one of the things that's become clear to me is that we can't think about a single task at a time, that any one task, even the operation span task, that probably 60% of the variance in that task reflects what I call working memory capacity / executive attention, because it turns out that attention is really the critical factor here. But, there are lots of other variables that affect that task as well, as it is true for all psychological tasks and tests, right? They're multi-determined, and that's something that many experimental psychologists just don't understand. So probably 10-20% of the variance, and I'm speculating there, of that task is due to math ability. People at Georgia Tech are really good. They look at that, the answer just jumps to them So the task is really not very useful for Georgia Tech undergraduates because that's such an easy thing for them. It also turns out that it's not a great task to use in aging studies because older people learned math without Texas Instrument calculators and computers, and so it's very easy for them. So that task doesn't discriminate working memory capacity in older people very well. There are many other tasks that are much better for that. So all of those studies have led me to believe that this thing that's really important is the construct that's important in all of those tasks and many other tasks that measure this construct. What's important is an ability to maintain your attention on some object or some event and to not have your attention captured away. And what is it that captures attention away? It's something out there, it's a light flashing across the street or whatever, but it's also internally generated thoughts. And that's really more of a problem in most laboratories, certainly, than is the external stuff, because we control that in the laboratory. What you can't control in the laboratory is a subject thinking about lunch or thinking about why this study is so stupid, why am I doing this? All of those are thoughts that, in fact, intrude and capture attention, right? And so this attention control turns out to be a really, really critical factor. And somewhere along the line, it became clear to me, partly it's because of a study Pat Killinan, who's at the Educational Testing Service now, pointed out to me, but we've done most of the work on it since then, is that this construct of attention control plays a really critical factor in what's called the biological aspect of intelligence. Intelligence can best be thought of as crystallized intelligence, which is everything you know, along with fluid intelligence, which is your ability to solve novel problems, reason, that kind of thing. And those two together make up roughly what we think of as IQ or intelligence. But fluid intelligence and working memory capacity are very, very closely related. They're not the same thing. They're related in the same way that height and weight are in human beings. We know that taller people tend to be heavier, but height and weight are different, right? And they tend to be correlated about the same level, which is about 0.7 to 0.8, and working memory and fluid intelligence are. But they're really different constructs, and we're working on what's the difference between those two. I have an idea now, but I won't go into that. It's too detailed. Turns out that this construct is also really, really important in lots and lots of real-world settings, as I said, but in some interesting ways. So it's not just that I can predict how good you would be at being an air traffic controller, for example, with an assessment of working memory, and I can. And it's one of the reasons, by the way, that the 4 big grants that I have now, 3 of them are really directed at assessing groups of people. So one of them is directed at assessing Navy SEALs. Who's going to be a good Navy SEAL? When people think of SEALs, they think of pull-ups and all of that and eating snakes in the wild and all of that. But it turns out to be a good Navy SEAL, there's a good bit of problem solving involved because you have these weird things that happen to you, like you're going after Osama bin Laden and one of your helicopter crashes, and things happen that you totally haven't prepared for in its entirety, and your ability to solve that problem is really important to your survival and the success of the mission. So this idea of attention control is hugely important. So one of my grants is from the Navy to develop assessments for Navy SEALs. It turns out that Navy SEALs are sort of they're not at the top end of a general distribution of human cognitive abilities. Physically, yes, mentally, but that's what we're assessing, and so we want to pick those people. We have another project that's funded by the National Security Administration to pick what they call cyber analysts. Big in the news these days, right? Edwin Snowden, who gave out the secrets, was a cyber analyst. And that is a different distribution of people. Those are at the upper end of the abilities distribution. And so they're almost certainly, the NSA will be using tasks that we've developed for them to assess cyber analysts over the next 5 to 10 years. I have absolute confidence that that's going to happen. What we also find is that this construct of attention control is easily affected by environmental influences. So I published a paper last year showing that in this study we had 10 highly skilled pilots. Right? Now, Anders Ericsson argues that skill trumps everything. Skill trumps differences in abilities, that deliberate practice, if you're skilled, and all those things are unimportant. Well, it turns out that's just not true. We had 10 highly skilled military pilots. Our most experienced pilot had over 5,000 hours of flying time. Okay? 5,000 hours in the air. That's a lot. The lowest was several hundred hours of flying time. And we had these people, they were in a lab down at Brooks Air Force Base. They were there for 30 hours of sleep deprivation. We tested them every 2 hours on a whole battery of tests. And one of the tests was this 4-axis simulator, the best simulator the Air Force has. And but along with that, we did several tasks, one of which was the operation span. And so in the second 15 hours of sleep deprivation, now it's not unusual for pilots to be awake for that long, or maintenance people or other people associated with aviation. We looked at their performance in this simulator. Now, nobody crashed the simulator, but we looked at deviation from perfect performance. So, if you think of this as the line that the pilot is supposed to be on regardless of, what situations occur, how far away does the line get from perfect? Okay, so deviation from perfect performance. Turned out that the operation span and another little attention measure accounted for 58% of the variance in that. That is, these little assessments as they go along accounted for 58% of the variance in this hugely sophisticated task. Right? So this measure is reflecting not just individual differences going into this task, but on a moment-to-moment basis, how capable these people are of allocating their attention to this task. Now, that's important. And at various times there's been talk about having commercial pilots tested online periodically. I just got back from Honolulu, 4-hour flight to LA, but it was actually a 9-hour flight altogether. It was a nonstop from Atlanta. And, but it's highly likely that person had been awake for a period of time before that. So this is really important. These are people who often are awake 30 hours. And so how does their individual performance affect your life if you're in that plane? Well, I think it would be good for us to know what determines how capable they are at the time. And even highly skilled people are not immune to the effects of sleep deprivation. We know that drugs, we know that depression, we know that something called stereotype threat in social psychology has a huge impact on this construct of working memory capacity. So if I say something to you that affects you personally, and that if you're a member of a minority group or you're a woman, and I say something about math, and men do better in math than women, that primes you then, and studies show that your performance in math is decreased substantially as a result of that. Well, it turns out that stereotype threat reduces your working memory capacity for all things. So even if the studies show that if I put you in what's called an antisaccade task, where you're looking at a fixation point, and at some point something will blink, like over here, our natural tendency is to look that way. Well, but in this task, you have to look over here, and we measure your eye movements, or we do it some other way. The stereotype threat reduces your ability in that task. That has nothing to do with math or whatever, but it's an attention control, executive attention task, one that we use all the time. So this construct is very, very general, and I think it's hugely important. It's the cornerstone of what we think of as fluid intelligence, and more this construct is being used in all of the areas of psychology. We now know that it's going to be probably important in determining the success of drugs in treating schizophrenia, for example. So I was in New Zealand right before Christmas, and Pfizer Pharmaceutical called me there, and they want to use one of the operation span task, in fact, one of our tasks, to determine whether a drug is effective in treating schizophrenia. Now, why would they do that? Well, it's because, as I teach my introductory students, there are 5 great symptoms for schizophrenia. Schizophrenia occurs in people 21 to 24 most commonly. It's a very critical period. And if you look at all of those symptoms and how strong they are, you've got delusions, hallucinations, those kind of things. But the one symptom that predicts whether somebody is likely to be remediated and made functional again is the amount of cognitive decline. That is, from pre-morbid to post-morbid, how much of a decline has there been in their cognitive capabilities? Well, there you go. That's what the operation span is all about. So they're looking at a drug that's what's called a D1 agonist. It's a dopamine 1 to 5 receptors for dopamine in the brain. And dopamine is really important to working memory capacity. We know that. And so this D1 agonist is a drug they're hoping it'll get through the blood-brain barrier and actually increase the amount of dopamine available to these people, and that will treat that aspect of schizophrenia. If that's successful, and who knows, it's all drugs are experimental at this point, and it could play a huge role in treating all of these homeless people that are out here, most of whom are schizophrenic and not treated. So this construct of working memory capacity executive attention is really important. I think, I'll be 67 my birthday, but I swear I'm as excited about my research as I ever was in my life. I think it's really important, and I just can't wait for our next set of findings. So that's more than you want.